As we continue on in chapter 5 today, we're going to talk about medians and altitudes, and then what they all three together make. So we've got a couple more centers to talk about today, or I shouldn't say centers, they're points of concurrency. What do I mean by concurrent? Okay, so if we've got at least three things that we're looking at, like three angle bisectors or three perpendicular bisectors, or today, three medians and three altitudes, if they all meet at one point, they're called concurrent. And so we've been naming that point of concurrency. We had two of them yesterday, circumcenter and incenter. Circumcenters were the three perpendicular bisectors meet, and it's the same distance to each vertex. The incenter was where the three angle bisectors meet, and it's the same distance to every side of the triangle. And that's just a quick summary of yesterday. So today we're going to have medians and altitudes, and we'll see that they make a centroid and an orthocenter. So a median. A median is a segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. Vertex of the triangle and the midpoint of the opposite side. So as you look at the median that's drawn in my example up there, does it appear that the median is perpendicular to a side of the triangle? 90-degree angle? Probably not. But it does go to the midpoint. Now we've done a construction, maybe haven't used it for a while, but we're going to do some constructions today. How do you construct the midpoint? Okay, the arcs, I call it kind of a football look to it. So you're going to be going, if I want to find the midpoint of AB, you're going to be making arcs that are like this to create really the perpendicular bisector. But we don't want that. We want to just locate the midpoint and connect to make the median. Okay, so grab your supplies. You've got kind of a big space on your paper there. I want you to draw a fairly good sized triangle. I don't really care whether it's acute or obtuse or right. But use a straight edge if you have nice. Yeah, just draw a triangle, fairly good sized. I want you to start constructing one median. So find the midpoint of one side by constructing and if your compass is kind of loose, grab a screwdriver here. I'll just let it up here in case you need one that you have. Okay, remember, you have to get the arcs crossing at 2 points before you can connect and find the midpoint. Really just need that to help you find the midpoint. Now connect that midpoint to the opposite vertex. Okay, getting one side done, do that to all three sides. I want you to do all three medians actually. And you've got to make sure these two cross. Otherwise this dash thing isn't really accurate. That looks good. Okay, now do that again. Yeah. fine. All right, are you getting all three of them to meet? What was your original triangle? This one? That's your original triangle. I don't even know which one is that. You didn't draw any medians. Okay, all right, let me have your attention up here. Okay, now if you're connecting correctly, you need all three of them or they will meet at one point. Now I need you to make sure that you are not just connecting the perpendicular bisectors. Because all three perpendicular bisectors, the things you've constructed, those will meet and make the circumcenter. But now we don't want the circumcenter, we want the median to make what's called the centroid. So in your picture, make sure you have connected vertex to midpoint, vertex to midpoint, vertex to midpoint. Okay. All three of those will meet at a point. Draw the medians, and they will all meet. Okay, so this point is called the centroid. While we're experimenting a little bit, I want you to take a look at your picture. Is this centroid the same distance from the vertex as it is to the midpoint? Is it the same distance on each side? No, it doesn't look like it? Okay, you're right. That centroid is not the halfway point, but there is a relationship. Got a ruler? Let's do in metrics because it's probably easier to compare. Measure how many millimeters on one of those medians. Measure from the vertex to the centroid, and measure from the midpoint to the centroid. Four on one part and 2 on the other. Hers was real exact. What other numbers are we getting? 0.9 and you got what? You got 1 and 3. Let's see. So you tell me. One of those was 1, and the other part was 3. How about the other part was the whole thing? Right. Are you finding that one of those is twice as long as the other? Might be a millimeter off or something. But yes, this centroid is not the midpoint, but it divides that segment into like 1/3 and 2/3. It's not half and half, it's 1/3, 2/3. So one of those is twice as long as the other. So we'll get to the theorem that talks about that, and based upon what measurement we start with, we'll figure out what the other lengths are. But that's a preview of where we're headed. I think there's a little bit in between as far as note taking. Okay, so the centroid is what that point is called. So you've got those 3 triangles. You can just do some sketching like I did. Why don't you go through and mark where you think the midpoint of every side is. And you're just doing some drawing now, so it's probably not as exact. But mark where you see the midpoint of every side would probably be. Put your tick mark so you know it's a midpoint. And then draw from that midpoint across the triangle to its vertex. So you're drawing the 3 medians in every triangle. So you have the vertex and that midpoint. Just like what you had forgotten to do up above. That midpoint. Estimate the midpoint of every side and then do the connecting. If you can't estimate real well, you've got a ruler there that could help you out. But you're mainly sketching so you have something in your notes to be looking at. Now, yesterday when we did this kind of thing with the perpendicular bisectors, there were some triangles, the obtuse triangle, the circumcenter was outside the triangle. And I think on that circumcenter, the right triangle, the circumcenter was right on the hypotenuse. So does the centroid end up outside the triangle anytime? No, we tried an acute, we tried an obtuse, we tried a right triangle. That's what those 3 are. So the centroid is always inside the triangle. The centroid really has kind of an interesting feature to it. If we would cut out your triangle, it would balance on the centroid. The centroid is the balancing point. You might write that down. Okay. The centroid is the balancing point of the triangle. Maybe I put it on there. So it's the balancing. Well, you know what to draw. I'm doing the same kind of drawing in all of them. Okay, balancing point. So if you want to take some cardboard and cut out a triangle and get it to create the centroid, see if you can really get it to balance, that would be a bonus that's offered during this chapter. You can bring it in and we'll see if it balances on a pen or a pencil or the top of a screwdriver, something, not this end of the screwdriver, but the tip of it, that type of thing. So we'll see if you can get a triangle to balance. Just heads up when you're trying to cut that out. If you use thick cardboard, you have to cut real exact because it's based on the weight. So if you're cutting poorly, you're going to get the weight distribution wrong. So maybe more like a poster paper would work better than a real thick sheet of box cardboard. But something more than just a sheet of paper. It needs to be a little bit heavier. Okay, here's the theorem about the centroid. We said that it was not half and half. So here's how they worded the centroid theorem. The centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So as you're going from the vertex, the centroid is gonna be 2/3 of the way. So that should tell you that from the vertex to the centroid is the bigger part. That's like the 2/3 portion. The centroid to the midpoint is the smaller part. It's 1/3 of the whole thing. So 2/3 of the whole median, or 1/3 of the whole median. So we'll go through some examples where I start you with one of the lengths. If you start with the whole median, like AY is the whole median, if you do 2/3 of the median, you'll get the longer part, AP. 2/3 of the whole thing. How do you do 2/3 of something? What's 2/3 of 30? 20 is the right answer. What are ways that you can get that? You can divide it by 3 and multiply by 2. Or if you're a fraction thinker, 2/3 times 30, 30 over 1, cancel down. So we've got a little bit of fraction work to do here. But let's see if you can do it right. In the triangle, notice that according to the markings, S is a centroid because of the medians involved. The length of RL is 27. I want you to grab your marker board, even if you do this in your notes. Find the length of LS for me. Things you need to think through on that median is LS the long part or the short part? So that you know whether you should be doing 1/3 of 27 or 2/3 of 27. Might help to write in your notes, the vertex to the centroid is the longer part. Your answer? Well, show me. Some are not quite ready. Those so far. Some more markers. Couple in there. Both of these are dried out.
Yeah.
Anyone else need markers right now? Okay, a few more to show me. Just don't take 2 seeds in there. Just take that one. Okay, 18 should have been the answer on that. Okay, those that didn't answer, getting stuck, you need to take 2/3 of 27. You divide 27 by 3, that's 9, times 2 is 18. How about the length of NQ? Now, this one's not exactly the same as the last one. I'm telling you what SQ is. Decide on that median, is that the long part or the short part? And I want you to tell me what NQ, what's the length of that whole median? You could do this more than one way. Show me. Any others to see? The answer should be 12. If this part is 4, did any of you think, okay, that's 1/3 of the whole thing? So 4 is 1/3 of NQ. So to find NQ, you could multiply by the reciprocal. So you could get 12 that way. Or if the short part is 4, the longer part is twice as much. 2 times 4 is 8. And then adding together 8 and 4, 12 is the whole thing. So there's a couple ways to do that. Can you do which one? Okay, which idea do you probably want to do? The 1/3 or the little parts? I did 2 different parts. Don't know? Okay, let's go this way. Okay, the short part was 4. The longer part's twice as much. 4 times 2 is 8. So then to get NQ, I just added 8 and 4 and got 12. Okay? All right. As I said, there's more than one way to think about it, and some of you are thinking one way, some are thinking others. Okay, let's try this one. You're supposed to find KW. KW is this whole median. So look for a measurement that's on that median. So which one did I give you? ZW, the short one was 7. So figure out the whole median. Right? Is all good? No? Yes. That's just the longer part, Riley. Now you need the whole median. Yes. Yes. Right. Any more to see? If the short part is 7, the longer part is twice as much. So 7 times 2, 14. The total of 7 and 14 is 21. Right, same picture, but I want you to find LZ. On that median, what measurement did I give you? Gave you LX. Is that the short part, the long part? No, it's the whole thing, right? So this is the whole thing. I want you to find the longer part. Is the longer part the 2/3 portion or the 1/3 portion? Those I saw here. Trying to do 2/3 of 8.1. Okay. Okay. So you need to do 2/3 of 8.1. Are you good with that? 2/3. Okay. So I think, are some of you taking 8.1 divided by 3 to find 1/3 of it, and then multiplying it by 2? So 8.1 times 1/3, you probably are thinking divided by 3, right? 8.1 divided by 3, but then you're taking it times 2. That looks kind of like a mess. I think that's what a lot of you are doing. What's it come out, 5.4? This is also 5.4. If you got an answer that was bigger than 8.1, that doesn't make sense. The whole thing's already 8.1. Part of it can't be longer than that. So think about the sense of your answer. Does it make sense over here, Rose? Understand calculating it? Okay. We are working on a centroid. What's a centroid made out of? Three. Look at your notes.
Medians.
3 medians. What's a median connect?
Midpoint and vertex.
Vertex to midpoint, correct. All right, now, I think on the assignment they're going to give you a few graph ones. Yeah, we're not done, but we just mentioned they're going to give you some points and ask you to find like the centroid or the circumcenter. We can do this one by like graphing it. Because couldn't we find the midpoint of each side? Probably by calculating, but that one I could visually pick out. Connect it across. There's one median. Let's see, another one. I think that point right there, 10 plus 6 is 16 divided by 2 is 8. 7 plus 6 is 13 divided by 2 is 6.5. So this point is 8, 6.5. That's another midpoint, so I connected. If I did those two right, I already know where the centroid is. The third one would just kind of verify where it goes. So I think the centroid was 8, 5. If I cut out that triangle, that's what it would balance on. I found a real interesting thing about this. If you average all the x's and all the y's, it gives you the centroid. 6 plus 10 plus 8, 24 divided by 3 is 8. 6 plus 7 plus 2, 15 divided by 3, 5. So I thought that was kind of interesting, that you can average all 3 x's and all 3 y's to find the centroid. But that's only the centroid. That doesn't work on some of the other ones that they'll ask you to find. All right, let's switch to altitudes and what's called an orthocenter. Okay, altitude, we'll probably do some constructing and use the marker board eventually. Altitudes involve perpendiculars, not perpendicular bisectors though. So just first of all, an altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side of the triangle. An altitude can be inside, outside, or on the triangle. So when we do the orthocenter, it could be inside, outside, or on the triangle. I want you to grab your compass because I found students aren't real good at estimating 90 degrees. So grab your compass, and I can't really use the compass on the smartboard, but I'll sketch what to do. Okay, on this first triangle, put the point of your compass on this vertex. And set your compass so that you can swing an arc that touches that side, that opposite side twice. Might have to go kind of small. So we get it to swing and touch twice. And if it's not working to stay in there, you might have to extend it out a little bit. But you need where it crosses that side twice. You might have to make that bigger the next time that I do that. Looks like it works better if you extend it. Okay, so some of you are looking confused. Take your straight edge. It's going to look more like number 2, it looks like. So take your straight edge and make that side bigger. Now try again. Point of the compass, swing the arc twice. From those 2 intersection points, down below, make an X. The same distance from each. We've done this construction before. on all three triangles. Here across these two. That X should help you create the red segment. Done on all three? So all I'm having you do is use the compass to help you draw a perpendicular. On the second one with the obtuse triangle, if you go from that top point, your arc is going to be maybe something like that. Maybe not even that far. Maybe it's looking like that, depending how big. So extend that side out there. And when you go from those two intersection points, you make the X. That altitude is actually outside of the triangle that you started with. That will happen if you're going in an obtuse angle or in an obtuse triangle. You might have to just extend a little further and open the compass right. The last one is a right triangle. And again, if you're constructing, you're going to have to extend this side out so that when you make the arc, you'll find that that altitude actually is right on the triangle. Because in a right triangle, it's already perpendicular when you go from that corner. Quite done. Now these 2 points, you need to make an X in those 2 points. You go from, looks like you went from that point to make your sweep. If you can help a neighbor, because it looks like some are right on track, others are a little confused. You're going to be doing these constructions on a project. So that's why I wanted to try and doing something today. So the X now will go across this side. So this point and from this point. Needs me to look at something. Okay, so you're creating one altitude. Now, if we put all 3 altitudes in one triangle, what would you guess is going to happen? Hopefully you'd say, you probably think they're all going to cross at one point. They're all going to be concurrent. Point of concurrency has a new name, which is orthocenter. Orthocenter is where the 3 altitudes meet. Now it's harder to estimate where the orthocenter is because it's kind of hard to estimate 90-degree angles without a protractor. Some of your packets maybe have protractors, but we're going to try and estimate those right angles. So here should match up kind of close with the 3 triangles that you've got. So let's just try and draw these rather than construct the orthocenter. So this first one, you made one that went straight down, right? That was perpendicular. Okay. If you turn your paper, you can maybe do a better job estimating, because horizontal and vertical you can visualize better. But from another vertex, as you turn the paper, estimate where it's going to make a 90. And from the last corner where it makes a 90. Notice these are not perpendicular bisectors. but it actually connects from the vertex. Go down to the second group of triangles. From the vertex to the opposite side, making a 90-degree angle. Your ruler can probably help you estimate 90s better than just eyeballing it. In the acute triangle, the orthocenter ends up inside. That's going to be the easiest one to visualize. Okay, second triangle. Okay, second triangle, you might draw in the one like you constructed. That one was outside of the triangle. Now as you turn the paper on the obtuse one, when you go from the obtuse angle on the obtuse triangle, perpendicular to that side, that's probably not too hard to estimate, but you're going to have to extend it. You can't just leave that segment. You've got to draw this whole line in order to find the orthocenter. So line up with the obtuse angle and draw a mark or lay your ruler where you think is perpendicular to that opposite side. Turn it like this way. It's going to be 90 degrees when it hits here, but then extend it. I think when you extend it, you almost hit the words for the next definition. And then can you get the last one? You have to extend this side to make a 90-degree angle when you come from this vertex. Turning your paper will probably help you. Horizontal and vertical, you can visualize. The right triangle is going to be the easiest because the two legs are two of your altitudes. The other one that goes to the hypotenuse, all three of those meet right on the corner of the right angle. The orthocenter does not have a theorem that goes with it because there is no specific measurement that is uniform. It's not equidistant from all vertices or all sides. You can't balance on it because especially if it's outside or on the corner of the right triangle, it doesn't balance. It's simply the fourth line of frequency. So probably what I'll be asking you to do on that one is simply draw where it would be. So what you're just now trying to struggle through, that's what I'll try and have you do, most likely on a test or quiz. So you'll probably want to get a protractor and use that as you try and do that. Okay, so vowel goes with vowel again today. So the altitudes make the orthocenter. Vowel, vowel. The consonants, the medians together make a centroid. So that works with today's lesson also. Okay, understand what you're drawing? All right, let's do just a few finishing things to see. Here's another type of problem. It says find the orthocenter. Grab the marker board. The back side. Back side has a graph. That has lots of scratches on it. When you put them underneath the desk, they kind of get scratched. Okay, this one says find the orthocenter of this triangle. So let's first graph that triangle. Make the sides as straight as you can. And it says to make the orthocenter. You were just drawing the orthocenter. So you have to create perpendiculars from each vertex. Sometimes you have to extend the side to get the perpendicular in there. Depends what kind of a triangle it is. Once you graph this triangle, where's the orthocenter? Draw an altitude, altitude, altitude. What kind of triangle are you doing? Right triangle? Okay, so look at your note. You do all the perpendiculars with the orthocenter of a right triangle and done. Okay, orthocenter should be right on the vertex of the right angle. Which was which point? Y. So the 3, 6 was the orthocenter. All right. How about on that same triangle, so don't erase too much, can you figure out the circumcenter? Circumcenter was yesterday. What's the circumcenter made out of? Perpendicular bisectors. So what's your triangle look like? This? Okay, you probably could do a good job, the perpendicular bisector of this side. Figure out where its midpoint is. Since it's horizontal, vertical, you should be able to do pretty good. Can you get that perpendicular bisector figured out? And then probably on the other leg, you can do a good job. Find its midpoint accurately. Draw its perpendicular bisector. To do perpendicular bisectors to make a circumcenter. I'm predicting that they cross on the midpoint of the hypotenuse. What is that point? So 5, 2. So knowing what thing you're creating, you can draw those. There are some mathematical ways to calculate it, but you can draw them. All right. How about, let's skip a second. When would you ever use this? Well, here's a situation. Oh, come on. City planner wants to build a new library. They want the library to be between the school, the post office, and the hospital. So we want it equidistant from the 3 locations, school, post office, hospital. Figure out, and kind of draw me a little sketch. So would this be the circumcenter, the incenter, the centroid, or the orthocenter? Which one's going to produce a location that would be the same distance to 3 other spots? Which center is it, first of all? You think circumcenter? Why would you say that? Can you justify yourself?
Sounds right.
Sounds good? Circumcenter was, what was that theorem? That it's equidistant from the vertices. Would the vertices be like 3 locations? Okay, so he was right. So it said draw a sketch. So what I would be doing is just drawing, I guess I got it kind of down in the bottom there, showing that it's perpendicular bisectors. So drawing a sketch just to put those in there. All right, let's do another one. I'm not gonna worry about the sketch right now. Circumcenter was the right thing. Okay, here's another city situation. We want to build a firefighter's monument in the park between 3 streets. Draw a sketch to show where the city should place the monument so that it's the same distance from all 3 streets. Is it circumcenter, in-center, centroid, or orthocenter? We want it the same distance from each street. So this would be in-center. What do you use to make the in-center? What did you say? That's circumcenter. In-center is made up of the 3 angle bisectors. We got a winner. So you would need to sketch the 3 angle bisectors in order to locate where that would be at. Excuse me? You said the in-center a while ago? So there are places that you would use this, and that's just an example. You could think of maybe doing something like that in a garden, or doing a fountain in somebody's yard, something like that. All right, so we did, just looking through a few things here. Here's another one, I guess. This is Frank, myself. Needs to hang a light fixture. It contains 3 lights in a triangular arrangement. I would have that kind of thing, right? Which point of concurrency must be used to have the light fixture balanced correctly? Centroid, correct. How would I make the centroid? Midpoint to vertex, because that's a median. Draw those 3 and you would find where to balance it. So you can imagine me as a geometry teacher would have that in my house. Okay, so you constructed today a centroid and orthocenter. We did 1 altitude. How would you construct a circumcenter? How do you do perpendicular bisectors? How do you find the midpoint of the side? From each end, do this construction. We did that one today. You actually want the perpendicular bisector. Don't change it to make the median if you're doing a circumcenter. Okay? You want the perpendicular bisectors. Okay? All 3 of them. How do you do an in-center? How would you, I'll try and leave that up there. How do you bisect an angle? Go through the sides of the angle, and from those 2, make the X to cut it in half. You do that on every side, or excuse me, every vertex, you're going to find the in-center. Why am I mentioning it? These 4 things to construct are really what your project is. I'm going to give you that project description right now. You're going to discover what's called the Euler line by doing constructions. I did the 3 whole bunch. The Euler line is made up of 3 of these 4 points. So it might be the circumcenter, the centroid, and the orthocenter. It might be another 3. I'm going to have you figure out which 3 and show me that on a triangle. So I've given you the actual size of the triangle and the directions there. And I would suggest you use some poster paper because it's a little thicker. Your compass can stick into it better and be more accurate. I would also suggest you use maybe some colored pencils, changing the pencil that you're drawing the arcs with, so you color code. Like all the orange are for the orthocenter, all the P is for the circumcenter, purple or something. So color coded, it'll be easier for you to follow and for me to grade. But basically, I'll let you read the details, but you're going to construct each of these 4 things and then figure out which 3 of them are collinear. Which 3 make a line. That's what the project involves. Not do tomorrow, but let's have it do Thursday. We've got a couple evenings to think about it. Okay? And I'll even give you one more heads up. It's an obtuse triangle. I would position it like this direction on your paper, not the other way, because your ortho center is gonna be either way down here or way up here, at one place. From the obtuse angle, it's gonna be actually behind the obtuse angle. So probably put it that direction.
So you would have to do them.
It doesn't have to be, but it probably will work better as far as the signs. I have poster paper up there. Okay, so the assignment isn't real long. Okay, so begin your project, and I think I got some extra packets of supplies so you can take a compass and straight edge. Maybe if there's a protractor in there, you might leave that with me. I'm short on protractors. And you really don't need that. You might need a longer ruler at times, or it doesn't have to be a ruler, a longer straight edge to connect something positive. So this assignment is, out of the book is due for tomorrow. That has to do with your centroid and your orthocenter. Begin that project, and it'll be due on Thursday. It involves construction, so you need some of those tools. And I'll be at monitoring tutoring tonight, so if you